This video will be problems on aromatic compounds. For the first question, we have to fill in the appropriate reagents for the reaction scheme below. For the first step, we are adding a methyl group. For this step, a Friedel-Crafts alkylation could be used. Next, we have a bromination on that methyl. However, this bromination is a benzylic bromination. That means we can use something like NBS. Next, we go from the alkyl halide to a hydroxy group. This could be a simple substitution reaction with OH minus. Next, for the final step, we are creating an aldehyde. We cannot use something like dichromate or permanganate because that will oxidize it all the way to a carboxylic acid. Therefore, to get just the aldehyde, we will use MnO2 to ensure that we get just the aldehyde product. For the next one, this is going to be a Friedel-Crafts alkylation. The CH3 group, this is going to be a weak activator. So this is going to be an orthopara director. Since we have a propyl group here, the para product will be favored to avoid sterics on the ortho product. Now, recall with alkylation, rearrangement can occur. So instead of getting a straight chain propyl with the carbocation on this carbon, we will attach this carbon here. We will get an isopropyl group. For the next one, we have Sanders reagent, and we have an amino acid here. So for Sanders reagent, nucleophilic aromatic substitution is going to occur on the fluorine. This is because we have two very strong electron withdrawing groups, ortho and para, to that group. Since we know this is nucleophilic aromatic substitution, we have to determine which atom is going to be the nucleophile here. And the correct answer is going to be the terminal amino group, because if you look at this nitrogen here, you can get resonance and move this double bond here and get a positive charge on that nitrogen, which decreases the nucleophilicity. Therefore, the product will be this. For the last one, we have to determine which position will be attacked most rapidly by a nitronium ion with a nitration reaction. We know this is going to be electrophilic aromatic substitution. And we know that activators are going to be faster than deactivators. Therefore, we will pick an activator over a deactivator. We have two groups we have a ketone here, and we have a methyl group here. So for a ketone, this is going to be a moderately deactivating group. And the methyl group is going to be weakly activating. Therefore, we will pick the methyl group over the ketone. Now, activators are going to be ortho-para directors. And since the para position is not available, we will pick the ortho position, which makes D the correct answer. That concludes the video on problems for aromatic compounds.